Welcome back in. Now we're going to switch gears and look at derivatives of log functions and or anything containing a logarithm. And so we've seen the derivative of a log function already, but we're going to do it slightly differently, right? So let's think about when we see a log equation, right? We can also translate that into an exponential. So we can also switch that into something where we have, say, a to the y is equal to x, right? That would be the equivalent exponential form. And then we can differentiate this, okay? And this requires logarithmic or implicit differentiation. So a to the y ln a is equal to 1. Y prime, I forgot y prime. There we go. Times y prime is equal to 1. And then y prime is equal to 1 over a to the y ln a, right? But then we just see that y prime, a to the y, I'm going to say that a to the y is just x. And so then I get my derivative, okay? And then also it's important to note that in the case of ln of x and we a natural log and we differentiate that, that's just going to be 1 over x because we'd have ln of e and ln of e is just 1, okay? The only thing with all this is, like I said at the end of my last video, look out for chains. So let's see if we can differentiate each one of these, okay? Y prime is equal to 1 over, it's a natural log function, so just x cubed minus x plus 1, and then I need to multiply by the chain of this, so this would be 3x squared minus 1. Okay, that's fine. Next one, so let's see. This is the same as saying log base 3 of t all to the 1/2 power. So then when I do g prime, this is going to be equal to 1/2 log base 3 of t all to the negative 1/2 power. And then times the derivative of the interior, which would be 1 over t ln of 3. This is a non-base e logarithm, and then multiplied by the derivative of the inside, which is just 1. So I'm done. Okay. Now h. You look at that and you're probably just going to plow ahead. I'm going to tell you you can do that, but just remember that there are certain properties of logarithms that you can maybe use to your advantage. This is k to the 1/2 power. And then remember that exponents inside of a logarithm can come out front as a coefficient. So this is actually just 1/2 natural log of k. The advantage of this form being you don't have to do a chain rule. Okay, so avoid chains if you can. H prime is just going to be 1/2 over k, or 1/2 times 1 over k, and you're done. Boom. Okay. So with that in mind, try these last two on your own and resume the video when you're ready to see the solution. And there are your answers. Okay. So in M, this is one where you definitely want to use the rules of logarithms to your advantage to break it up into multiple logarithms, because otherwise that is a nasty product rule within a quotient rule with several chains, and yeah, no, don't do it. So this one very much made use of the properties of logs to solve. With W, that one you might need to look up the derivative of an absolute value function. It actually ends up being this last piece, so the derivative of absolute value is y, like y over the absolute value of y, and then you had to go through some algebra to get that to simplify correctly. So just make note of that for the back of your brain, just so you're aware. Okay, so that is what we need to mention about logarithmic differentiation, or sorry, derivatives of logarithms. And next, as you can see on the bottom of the screen, we're going to talk about a different process called logarithmic differentiation and when you might want to use that.